Hello everybody, welcome back to the shop and F-14. No how-tos today, or at least not right now. Years ago, I had 2 horizontal stabs done. Not anymore. I decided since I had some extra material and some time is, well, I got plenty of time, sort of. Anyway, I had extra material, so I did a lighter layup on horizontal stabs. Instead of using 3mm core, it's only 1mm core now. And it's the same stuff I use on the fuselage. Same stuff I'm going to use on the tail, or on the vertical stabs, wings, all that stuff. Anyway, now you see both horizontal stabs are laid up. And yeah, so that's the horizontal stabs. Over here on the other table, you can see a whole bunch of stack of stuff. I've got the material right there cut out for those 2 things, that one and that one. That's the insides of the inlet ramps. And the other thing I haven't shown you guys is this monstrosity. Anyway, this is the that center wing spar. It's the same surface coat that I used on the fuselage and all the other molds. I just added some graphite powder to it, and that's why it's got the gray color. Anyway, this thing is prepped and ready to get laid up. Can't really see it from that point of view, but let me zoom in over there. And right there, the little black shiny stuff is about $300 of carbon fiber for this alone. And there's some core material up there too. So all the stuff for that's cut out and ready to go. Tail section is going to be done once I get these vertical stab or horizontal stabs done, and then the rest of this fun has begun. So let me zoom in here and get you in the table, and I'll show you the cool stuff. Bought some of the machine parts for the F-14. Wing pivot brackets. Not just one, but 2. These have been, well, they're machined out, they're ready to go. Bolt holes. So those are ready to have a wing bolted to them. Little axles here for the pivot bearings. See, it's, well, you can't really, anyway, it's threaded in there for an aircraft bolt. And then these little tamales. These things are expensive. $60 for one bearing. Yeah, that's right, 60 bucks. 40 bucks for the bearing, 20 bucks for the race. It's a little baggy. Costs more than the titanium for the horizontal stabs. Anyway, basically, this goes like that. 2 bearings, the axle. Of course, there's the cups on it, or the races, whatever you want to call them. And this goes here in between the pivot bracket. A couple aircraft bolts hold it together, and then that little machined adapter thingy that I machined up that's inside the wing is what that those races push down into. So that's basically the whole wing pivot assembly right there. Why am I spending 60 bucks on a bearing for this wing pivot instead of a $20 ball bearing? Same principle as your car, the hub bearings on your car. They're tapered. The tapers go opposite direction. Okay, now the best thing, now turn it off. Tapers are opposite direction. Because they're in opposite directions, or where they taper into each other, go this way, your wing incidence will not change ever unless the bracket or the wing breaks, or the interface between the machine part and the wing skin. That's why I've got that lip on the machine part and the wing skin, so the wing skin actually wraps around the aluminum piece, so it's not just a glue joint holding it together. The ball bearings, they're good for radial loads. Thrust bearings are good for thrust loads. These are good for both. So not only do you have the loads from the bearing going this way and this way, but you've also got them going this way as it sweeps. So this is going to keep the incidence exactly where you want it, and it's going to make it very easy to pivot forward or sweep forward and aft because of the thrust capabilities of it as well. That's why $120 in bearings for one wing panel. So that's kind of the boring part of getting the height going. Then we got this big old thing. This is the whole horizontal stab pivot mechanism, the mount, servo mounts, everything. It's technically 4 pieces. You got the pivot arm here, you got the support for the shaft, which is here, and you got the servo mount as well. 2 ball bearings, one on either end. You can see the little 440 screws here, button head bolts holding the bearing into place. Another one on that side. It's a 1/2 inch ABEC 5 or ABEC 7 bearing, I forget, I think it's ABEC 7. So it's a really high quality bearing. And there is exactly 10 thousandths of side to side play between each bearing for this pivot arm. It's the joys of working with CAD. You can sit there and get this stuff to where there's like absolutely, well, technically I could get that to where there was no side play whatsoever. But a little bit's alright. For the first gen parts, I'm happy. Those 2 servos, one here, then a lightning bolt or whatever. Reason why 2? AMA large model requirements. Believe it or not, this thing it needs a lot of torque. So because of that, I'm gonna run 2 8711s or 8911s in here. I haven't decided what. I've got 2 of each sitting around. So either way, I got my 2 of something else. The arm here, see this pull set up. 3 holes, 1 inch, 1 1/4, and 1 1/2 from the center of the pivot shaft to the center of the hole. So you can get some really good leverage going on there. They don't move a lot. It's only about, I don't know, 10 degrees from vertical, either direction. That's probably all you'll need for deflection on the elevator. I don't think you'll need a whole lot. So there's that, and of course the 1/2 inch titanium pivot shaft. And that's the whole reason why, well, one of the reasons why I decided not to use those other vertical or horizontal stabs. They were heavy, and I needed the shaft back out of it. Because when I sized this thing, 1/2 inch shaft, 1/2 inch bearing, 1/2 inch bore, and servo, and the control arm, yeah, it's all press fit. So you actually have to undersize one of the part or oversize the other. Since I can't oversize the bearings because they get really expensive when you ask for an oversized bearing, I had to pull the shaft out and actually turn it down a little bit on the lathe. By a little bit, I mean like 5-10 thousandths. Very small amount. Anyway, 2 of those. For those wondering. Also, today, what I did is I took some 1/2 inch aluminum, undersized one end of it, and these will actually help me mount up those stab mounts that you just saw into molds. If you remember, I sat there and molded the pivot locations into the flanges. So you put this in place, slide your mount over, use that to hold your bulkhead in, close it all in, and then the 5 degrees of anti-drone on the stabs are already in there. So there's that. And what other cool little stuff do I have? Well, I got some stuff. First, y'all saw the big high saw gun. Well, big tubes of high saw, 7 ounces, almost 7 ounces. Got 2 of those. Everything's gonna be high sawed into the fuselage, the wings, everything. I'm not gonna make up a spooge for the majority of it. Some of it I will, some of it I will not. The high saw is going on everything that has a lot of lot of force to it, such as gluing in that carbon box bar, the majority of the fuselage bulkheads, all that fun stuff. All right. Anybody want to guess what this is? If you said the rim for main tire, you're right. Sat there, and once I got the sample that I showed you guys last time, I made a few little changes to it. Nothing major, just kind of some stuff to make joining it a little bit easier. And then instead of the 080 screws, I put 256, just because the 256s are a little easier to come by in most towns. So I figured if anybody ever lost one of the screws or the bolts or whatever, make it a little easier. Yeah, it's not quite, it's a little bigger, it's a little, well, it doesn't look as good in my opinion, but the ease of use makes life easier. Ball bearings, both sides, 1/4 inch diameter titanium axle. Yes, I know, I'm going titanium crazy, but it's gotta be strong, it's gotta be light. This is actually 2 pieces I just got bolted together. You can kind of see the seam line in some ways. It's just on this side of this part in the middle of it. Anyway, these things are 5.5 ounces a piece, 6 ounces a piece. Yes, I bought 2. So main rims are here. I do have a custom done brake back here. I haven't bought them yet. I'm still kind of working on some stuff. I'm trying to decide if I want to do disc brakes or what. That's why you see all the holes in here, and why I didn't get rid of a lot of the material in the back sides, because I wanted to have the option of running a disc brake set up that I've got in my head how to make it work. I just need to get in CAD and start drawing it up and seeing if it's feasible. Then there's this thing. For those who saw my tire molding 101, well, I'm about to give you my tire molding 202 or 102 or 10s, whatever. This hunk of metal, both pieces, cost more than everything I just showed you that was machined combined. And on the tire molding 101 video, I told you guys I was having a tire mold machined out of aluminum. Well, this is it. I played hell getting this thing apart. Again, the noob in me as far as machine parts and fits and tolerances and all that stuff. When I drew up the CAD in here for this part, I forgot to take into account slip fits, press fits, and all that stuff. So when I had them cut this little hole here and the little knob here on the center of the other part, so they would mesh together perfectly on center every time, I forgot to specify it was for a slip fit. So what I got was a extremely tight slip fit, to where they were put together and they had twisted and the aluminum had galled each other, so they were basically locked together extremely tightly. That's why you see the faces are all dented, trying to get them apart with chisels and flat-headed screwdrivers. Anyway, the flange around here is all kind of gummed up and nicked and everything, but the tire molds are, the actual tire surfaces are good. Since, well, there's a lot of things here in the U.S. we can't get away with. Some of them are trademarked items and copyrighted items, and Goodyear's little flying wing is one of those things. So you can see here, I've got it machined, and I've got Goodyear in reverse, but I don't have the flying wing in the middle. Why? That whole trademark and copyright stuff. There's a lot of little writing that is on right around the bead of the real tires that I left off on this, because this stuff was so small. I mean, you're talking about something that was going to be 3/32 of an inch tall and about the same width per letter. I mean, it was so minuscule. It wasn't really worth the time, and it probably wouldn't even come out in the part. So all I did is I put the big noticeable stuff, the Goodyear aircraft rim, and it's on both sides of the mold. You can see it written on that one too. So these I cleaned them and I have prepped them, and I'm having second thoughts on stuff. Typically I use a 2-part urethane rubber from Smooth On. It works extremely well. It's available in multiple durometers, anywhere from 10 to 90. And for those out there, do not use a 90 durometer rubber for your tire. That thing is like a hockey puck, literally. I mean, it is, when you first pull it out of the mold, it's hard and you're like, oh, this is gonna be perfect, the perfect durometer rating. Well, after about a week, it goes from a tough, rubbery, hard to a hockey puck. You can't even drill it hard. It's way too hard for anything. The second problem with that stuff is it's heavy. The Yellow Aircraft F-18 tires I did, I think they came out around 3/4 of a pound for a pair of them. And they are a little bit smaller than these. I think they're about 1/2 inch or an inch smaller than these tires. So with a pair of rims that are just under a pound, they're about 3/4 of a pound, and then a set of tires that would be a pound apiece, come about 3 pounds for just wheels and tires. Yeah, it works. I could get it to lift it up, I'm sure, with electric or whatever, but it's just too heavy. I mean, 3 pounds for just wheels is nuts. So what I'm looking at is a couple of 2-part urethane foams. They expand, kind of like what you would see on Dubro or Sullivan's tires, but they also have a self-skinning property to where when you have a closed mold and you clamp up, it sits there and it expands, but once it gets to the point where it expands and it's kind of constricted from expanding anymore, the outer layers actually of foam get a little bit denser and less foamy or less aerated, and it starts to build up a skin. And the more the stuff expands, depending on what you buy, dictates how thick that skin is and how durable it is. The big question is, what density foam do you go with? Do you go with a 1 pound or do you go with a 25 pound? I mean, there's there's a fairly large variety of densities. So the other problem is that stuff uses a different mold release than what I've got for the 2-part urethane rubber, which isn't really that expensive. It's just hazmat, so it has to go hazmat on USPS or UPS. So I'm kind of waiting. There's no big rush on doing these tires, so I'm kind of figure it out, see what happens, and we'll go from there. But that's where I'm at with the whole F-14 thing. I gotta go to town again on the 14th for a couple of days, going somewhere in California. But come back. Hopefully we can get this thing done. I gotta order some plywood for the internal fuselage. Majority of it's gonna be 1/4 inch aircraft ply that I get it from Aircraft Spruce. It's not like the stuff you see at a hobby shop where it's like 5 or 7 plies. This stuff is 12 plies. It's some really dense and hard stuff. So I can't remember if I showed you guys or not. Whenever my buddy Chris's place, we kind of took some time and I drew up some parts in CAD. And by parts, I mean bulkheads. Let me zoom out of here. See, this is the horizontal stab bulkhead. This is just some cheap Luan plywood. It's 5mm underlayment plywood from Home Depot. It's cheap, 4x8 sheet, $14. And these 2 bulkheads plus 2 more a little bit bigger and some other parts took like 1 16-inch by 8-foot strip of that plywood to cut out. So I mean, I do 3 sets of bulkheads out of 1 piece of plywood from there. These are just templates. The reason why we use this, we stuck it in a CNC router, cut everything out just to test the fit of them, so I can, before I go out and spend $200 on plywood and carbon fiber and epoxy to laminate all that Aircraft Spruce plywood, I can make sure they all fit and everything goes well. Anyway, this is the rear stab bulkhead. You can see tons of lightning holes in this thing. Try to keep it light, it's the name of the game. Bolt holes are already here for the horizontal stab mechanism, which they will essentially go here. Well, it's backwards at the moment, but that one will go over here, and then whatever, this will go there. And these are the mounts are actually back on the servos. But there's these two. Again, the anhedrals are already built into the airplane. And then there's another bulkhead that mounts between the tops of these that goes across. Just the top part, it doesn't really need to go across the bottom, but and that's your whole thing. All of this is leverage between two bulkheads and that fuselage skin to hold these stabs in place. So there's that. This bulkhead goes just behind the overwing fairing hatches. They're also notched as well for the turbine mounting rails. And then you can see there's two kind of square holes here and two rectangular holes here. There's two longerons or whatever that run right down the middle of it, and the tanks, the fuel tanks also sit through there. This opening here will probably get removed altogether, or it'll get combined with this one up here, so the tanks will slide in through here. Tanks can be really long and baffled, I'm thinking. I haven't really decided too much yet. We also did a couple other parts that, these are really the only two that fit. That carbon wing spar, this is the forward bulkhead for that. I had to cut it in half to get it to fit and everything, but basically carbon spar sits here across the top. It's there, and then it gets high solid epoxy and all that good stuff, and then it gets high solid to the top of the fuselage skin, and then it'll have everything down here at the bottom. This thing sits there and it basically connects the top fuselage skin, the wing pivot assembly, and the bottom fuselage skins all together to make one big box. And then there's also this one here. Again, I had to cut it in half to get it to fit. Same thing, box spar, turbine mounting rails, and then some portions of the main landing gear mounts all get into this. These mounts also transfer to the front one. Everything gets triangulated and tied together. This is that part that I told you about for the forward mount for the horizontal stabs. It used to look like that. It didn't fit. It was just all off. So it's getting cut down to where it just goes across the top, and then it'll connect into those longerons right here as well. Anyway, there's some visuals for the structure for all you guys wondering what the heck's he talking about. So I got all that going, and it's just a matter of getting the time to get this stuff done. I gotta help my buddy Chris lay up one of his A10s here pretty soon in exchange for him machining out those bulkheads, and he's also gonna start machining out some cockpit stuff. And yep, anyway, that's where I'm at. I got a ventral fin I gotta lay up in those inlets, so maybe I'll pop in the video camera and talk to you guys for a while. I don't know, we'll see. Oh, I also got this little monster in the mail today, or yesterday. Another little project I'm going to work on, a little hot liner, sort of. So anyway, maybe I'll do a build thread on that thing. It's an X-plane from Yuri's Composites out in, I think it's in Portland, Oregon. Should be a fun little hot liner, 200 and some odd mile an hour is what I'm shooting for. That's a Contronic mini pyro outrunner for a helicopter that's going to go in the front. So anyways, that's where I'm at. Alright, once I get aircraft, these bolts for this thing, which I gotta get from work tomorrow, I'm gonna start load testing that outer wing, that wing panel that I've already got laid up. So here pretty soon, we'll have something cool to do. So anyway, you ladies and gentlemen have a great night, and we'll see you back here in the shop next time.